Solving systems with decimals. So when we're going to solve a system with decimal, the first thing we want to do is get rid of the decimal. So what we're going to do is look at how many digits are behind the decimal. So I have one digit behind this decimal, and I have one digit behind this decimal, which means that if I multiply this number by 10, it's going to move that decimal one place to the right. So I'm going to multiply that by 10. I then have to multiply everything else by 10. And then I'm going to come down here and notice that I also have a decimal. So I'm going to multiply that by 10. And I'm going to multiply the y by 10. And I'm going to multiply the 3 by 10. Now, if I had two numbers behind this decimal and I needed to move that decimal two places, then I would multiply by 100, 100, 100. And if this one also had another digit, for example, 2.25, and I wanted to move that decimal two places, then I multiply by 100, 100, 100. Remember that when I'm multiplying the system, everything in the system gets multiplied. So now my new equation that I'm working with is going to be 10x plus 10y is equal to 34, and 30x plus 10y is equal to 22. So now I have no more decimals. Now I'm going to be looking for, where do I see my zero pairs? So I have a positive 10 and a positive 10. If one of those 10y's was negative, I'd have my zero pair. So what I'm going to do is I'm going to go ahead and multiply the first one by negative 1, negative 1, negative 1. So I'm going to have negative 10x plus negative 10y is equal to negative 34. And then 30x plus 10y is equal to 22. Now I'm going to go ahead and solve. So my y's cancel out, leaving me with 20x is equal to negative 12. Now remember, I know by looking at my original equations that I'm going to have probably a decimal answer, because I'm going to need some sort of a decimal up here that when I add another number to it, I end up with 3.4. So I'm going to go ahead and I'm going to divide by 20, and x is going to be negative 0.6. Come back up to the original equations. I'm going to write my ordered pair, which is going to be negative 0.6. And then I'm going to take x plus y is equal to 3.4. I'm going to put negative 0.6 plus y is equal to 3.4. Y plus negative 0.6 CPA is equal to 3.4. Add 0.6, add 0.6, so my y is going to be 4. So now I'm going to go ahead and do my checks and see if I'm right. So the first thing I'm going to check is x plus y. Try that again. X plus y is equal to 3.4. Negative 0.6 plus 4 is equal to 3.4. I have more positives here, so how many more do I have? I have 3.4 is equal to 3.4. So that one works. And then I'm going to go ahead and I'm going to check 3x plus y is equal to 2 decimal 2. 3 times negative 0.6 plus 4 is equal to 2.2. And then I have negative 1.8 plus 4, and that's going to be 2.2 on the left side, and 2.2 on the right side shows me that my check works. So as a recap here, if you're starting out with a system that has decimals, multiply by whatever number you need to that's going to move that decimal out and give you whole numbers. That way, when you solve, even if you solve and you get a decimal for one of your ordered pair coordinates, that's still okay, but it's going to be simpler to solve without that decimal there. And that's how you solve systems that have decimals.